So this is the second example problem for impulse is equal to change in momentum. This would be using the bumper boats. They still have them, I think, at Cultus Lake, but they're a lot like the bumper cars that we did at Castle Fun Park, but there's no friction. So when you get bumped, you'll keep on going until you hit the bumper on the other side. So this is a top view of the pond, and this would be like the course that you have for the bumper cars at Castle Fun Park. These are bumpers, so when the boat hits the bumper, it'll actually bounce back out. In this example problem, the bumper boat is traveling west at 3 meters per second. This is a top view of the whole arrangement. So what'll happen is when this bumper boat hits the bumper, it'll come in and then bounce back out. And we'll take a look at that problem in a minute. So the rest of the information here, the mass of the bumper boat is 85 kilograms. The final speed of the bumper boat is 1.0 meters per second to the east. So it was originally going to the west at 3 meters per second. And to the west means in the number line negative. So it was initially going negative 3.0 meters per second. You have to include negatives and direction in momentum because momentum is a vector. So VI in the equation has to be written as minus, because that's to the west, 3.0 meters per second. And that would mean 3 meters per second to the west. You don't need to put to the east here because plus 1.0 meters per second means to the east. The time duration for the collision with the bumper was 0.55 seconds. The question would be, what is the force felt by the bumper boat? So writing up the information in the equation, impulse is equal to change in momentum, it would look like this. We're trying to find the force, so we don't know that thing. But we've got all the other bits of information, got all the other data. So force times time 0.55 is equal to mvf, which is 85, times vf, which is 1, minus 85 times minus 3. Be careful, you have to put that negative in there. And if you do the math, you get force times 0.55, same as before, is equal to 85. 85 times 1. Minus 255. And if we calculated the answer now, this would just be 85 plus 255 is equal to force times 0.55. So you get force times 0.55 is equal to 340. And just finishing up the calculation, force is 340 divided by 0.55, which equals 618. I'll check it. 618. 618 newtons, and written so you can actually read it. 618 newtons. And that's a pretty substantial force. And that's it for now. Have a good week and enjoy that sunshine when it comes back. Bye.